Till now, we have already seen the individual fabrication steps in integrated circuits. Now we will see how these steps are used one by one to make N or P-type transistors and ultimately a CMOS fabrication, how it can be done. So actually we need to accommodate both N and P-type devices onto a same substrate to make a CMOS. So the CMOS technology can be N-well, which is desired if we are using a P-type substrate, or a P-well, which is there if we are using N-type substrate. Okay, the process starts with creation of N regions for PMOS and P region for NMOS and vice versa, and process step is ion implantation when we are talking about the CMOS technology. And we will see step by step, okay, how it is done. So let us first see the fabrication of NMOS in VLSI chips, how it starts. So it starts with the P-type substrate, and then we grow the oxide layer onto this substrate, and the thickness of this oxide layer is around 1 mm. This process, the growth of oxide, is known as oxidation process. After that, the photolithography steps will start, which is the application of photoresist. It can be positive, negative. Depending on that, the mask will be used. It will be exposed through the radiations. And here, ultraviolet rays have been shown in the figure, where the mask is, the pattern is being exposed through the mask onto the photoresist. Okay, and this photoresist is then developed, and after developing, then the process of etching is there, which will remove the unwanted silicon dioxide from the desired window. Now these oxide which you see at the corners, where the window has been created, there are the thick oxide in the corners. These are also known as field oxide. Field oxide actually are the oxide regions which are other than the gate oxide. So the next step is the growth of gate oxide. So a very thin oxide layer is grown over the silicon substrate first. Then a polysilicon layer is deposited, and this polysilicon layer is patterned again using the photolithography or any other lithography process, and then it is etched. So only the polysilicon part will be left here, and after that, this thin oxide, you can see here the polysilicon under which there is a thin oxide and then a substrate. So actually this has defined the gate region of the MOSFET here. Now if we remove the oxide from the sides of the polysilicon and we dope the impurity into it, it will, depending on the impurity, it can become N or P type. Okay, so here you can see the extra oxide which is not desired has been removed from the sides of the gate here, and N plus regions are doped, so it has become N type MOSFET. N type enhancement type MOSFET has been fabricated. Then insulating oxide is further doped, and between the insulating oxide the regions are made so that aluminium can be deposited to make the contact of this transistor with other transistors and devices on the integrated circuit. So all these steps, that means oxidation grows the thick layer of oxide. Apart from that, the thin layer and polysilicon or aluminium, they are grown using vapor deposition processes. So this is the figure. First figure shows the metal has been doped here, and finally the metal contacts are patterned, and the interconnections are made with other devices. So in a similar way, we have a CMOS N-well fabrication. So if it is a CMOS N-well fabrication, that means the starting material will be a P-type substrate over which a silicon dioxide layer is grown using oxidation process, and after that it is subjected to photolithography process, so that now first the N-well will be developed in this substrate. So photoresist is applied, it is exposed through UV radiations through a mask, and it is developed, photoresist is removed, etching is done, oxide is removed, and now the photoresist is stripped out. After that, the N region is ion implanted or diffused to create the N well. Now further, we can have a P well in N-type substrate. So these are the steps. So after N well, the polysilicon, a thin gate oxide is grown. After that, a polysilicon layer is deposited. Then it is patterned, and only the region where gate is required, we will keep the polysilicon. So you can see that we require gate in two areas here. One region is for N-type NMOS and other area is for PMOS. So in N-well we will make PMOS, and in P where you can see the polysilicon gate region with this brown and yellow area, there we will make N-type material. So again we will have an oxidation process, then keeping windows open only for N-type regions, we will keep them open, diffuse N-type impurity, then again oxidation will happen. Now windows, in the next step, photolithography process will be done to create windows for P regions. Then P-type doping will be done. Then insulating gate oxide will be doped. After that, contacts are created to create the connections between, because now they are N and PMOS are created. You can see in the pink region and in the blue region there are now two transistors. Now we will have the contact where the common gate will be deposited on the both, and similarly we will have a contact where it will be connected to ground, and one contact where it will be connected to VDD. So this is the entire structure of a CMOS.